Okay, so it is lesson 3.3, slopes of lines. Let's kind of look at the objectives here. We've spent a lot of time talking about parallel lines and determining the congruent angles. Today we're going to focus on the slopes and determining, using the slope, whether lines are parallel or perpendicular. We've got a couple real life pictures here of some things that might represent slope. We've got a skier, and we've got a roller coaster, and we've got, looks like a guy mowing the lawn on a slope or on a hill. Our primary formula for slope is y2 minus y1 over x2 minus x1, so you probably want to get that written down in your notes. I'll put a little box around it. Sometimes we refer to slope as the rise over the run, or the change in y over the change in x. If we look at this picture here, anytime you identify 2 points on your graph, you can always count up and over. So if I start at this point, I could count up 1, 2, 3, and I could count to the right, looks like 6. So that would tell me my slope is 3 over 6, or 1 over 2 reduced. It doesn't matter which point you start at. If you would have started at this point, that would have been down 3, which is negative 3, and left 6, which is negative 6. So negative 3 over negative 6 would also give you positive 1/2. Hopefully that is coming back to you from Algebra 1. Leave that up there. Okay, so we're going to look at an example of each of the 4 types of slope. I'm going to take you through the method using the points, and I'm also going to talk about how you can do it, just doing the counting method. So on this one, if we know that t, the point t is negative 1, negative 1, and we know that the point s is the point negative 3, 1, 2, 3, 4, 5, 6, negative 3, 7. Again, remember our formula is y2 minus y1 over x2 minus x1. If I label my points, here's x1, y1, x2, y2. If I fill them in, I get 7 minus a negative 1 over negative 3 minus a negative 1. So on the top, I would remember whenever you have 2 negatives, that makes a plus. So 7 plus 1 would be 8. Negative 3 plus 1 would be negative 2, which gets me a slope of negative 4. If I'm going to find the slope using the counting method, if I started at t, I'd count up 1, 2, 3, 4, 5, 6, 7, 8. So I'm rising up 8. And I'm going left 2, so it'd be negative 2. So 8 over negative 2 would still get you negative 4. So again, that would be another way that you could look at that particular problem. Okay, on example 2, we've got a vertical line. So again, we could do the vertical count from Q to P. We know it's 1, 2, 3, 4, 5, 6, 7. So we're rising up 7. How far are we running, left or right? 0. So we would say here our slope is 7 over 0. Anytime 0 is on the bottom, we call our slope undefined. So a vertical line will always have undefined slope. And again, you could have used the points and used your slope formula the same as if I were counting. On our third line here, again, we're finding the slope. Let's do this one using the formula again. So here's my points, -2, so G is -2, -5, and F is going to be 1, 2, 3, 4, 5. F is going to be 6, 2. So if I do my Y's, 2 minus -5 over 6 minus -2. Same thing as saying 2 plus 5 over 6 plus 2. So my slope here would be 7 over 8. Example 4 is a horizontal line. Again, if I start at X, my rise, I'm not rising up any, so it'd be the rise is 0 over the run. So from from X to Y, 2, 3, 4, 5, 6, 7, 8. So 0 over 8 is just 0. So horizontal line is going to be 0 slope. I like to use the analogy of the skier. So I've got a little summary sheet here of our different slopes. We call it the slope dude. The way I kind of think of it is if it's a horizontal line and we're skiing, we're not going to go anywhere without a lot of work. So we're going to stay in place at 0. If I'm skiing on an undefined slope or a vertical slope, think about if I was standing at the top of the cliff and I'm going to just ski straight down, I'm probably not going to make it. So I'm going to be undefined as a skier. And then your positive slope, up and right, both of those directions are positive. Negative, we're going up and to the left, which to the left would be negative. Or we're going down, which is negative, and to the right. So hopefully that kind of gives you a good summary of the different types of slopes there. The next topic we're going to talk about is, and this is kind of our next point of interest here, is understanding the difference between parallel and perpendicular. So our slopes can tell us if lines are parallel or perpendicular. If the slopes are the same, which I'm going to put a box around those words, same slope, then we know the two lines are parallel. So if you notice in your picture over here to the right, this line has a slope of 4, and this line has a slope of 4. So those two lines are not ever going to cross. They're going to be parallel. Now for perpendicular lines, the lines that form right angles, which we learned in chapter 1, these slopes are going to have opposite reciprocal slope. So well, what's opposite reciprocal slope mean? That means that we're going to take the slope and we're going to flip the fraction, and then we're going to take the opposite sign. So we'll do a few examples of that. If I told you that the line has a slope of, let's say, 1/2, the parallel slope would also be 1/2. The perpendicular slope would be, we would flip it. So when you flip it, that's 2, and you take the opposite sign, that's -2. So parallel is the same, perpendicular is opposite reciprocal. Let's do a couple more of those. If slope is, let's say, -3, what would the parallel slope be? -3. What would the perpendicular slope be? It would be just 1/3, or 1/3. Let's do one more of those. Let's say the slope is 5/4. Parallel slope and perpendicular slope would be -4/5. Questions with that? So let's take a look at what your parallel and perpendicular problems are going to look like. A lot of them are going to look like this, where you're determining whether the lines are parallel, perpendicular, or neither. So notice in this one it says determine if FG and HJ are parallel, perpendicular, or neither. And then they're giving you the values for each of the points. Now we're going to omit the graphing part, so we're not focusing on the graphing as much as just determining parallel and perpendicular. So I'm going to start with FG. In this case, FG, I'm going to do -1 minus a -3, -2 minus 1. So that's going to give me 2/-3. I'm also going to do HJ. Again, we're finding the slope here of HJ. So 3 minus 0 over 6 minus 5. That's going to give me 3/1, which is just 3. So once we find the slopes, then we're going to determine, are they parallel, perpendicular, or neither? What do you think? Neither. This would be neither, because they're not the same, and they're not opposite reciprocals. So you would say this one is neither. We're also going to go through a few where we have the equation. So if I gave you this, y equals 2x minus 6, and y equals, let's say, -1/2 x plus 7. I said, let's look at these two equations and determine again if they're parallel, perpendicular, or neither. Hopefully we're okay with being able to do that. We're going to identify the slopes. The first one, the slope would be 2. The second one, the slope would be -1/2. So what does that tell me about my lines? Yes, so we would say these two lines are perpendicular because 2 and -1/2, they're opposite reciprocals. So we would say that those are perpendicular. Let's do one more. Let's say we have y equals 2x plus 5 and 2x plus 3y equals 6. Now on this one, we've got to be real careful. The first one, the slope is 2, but this second equation is not in slope-intercept form. So we have to get y by itself. So to do that, we'd subtract 2x. We get 3y equals -2x plus 6. Divide by 3, so y would be -2/3 x plus 6 divided by 3, which is 2. So this one would be neither, because the slope of this line is -2/3.